Have you noticed how the world has gotten a little bit smarter lately? It's not just you. Your phone seems to know which photos have your kids in them. Your favorite music app creates playlists that feel like they were made just for you. Even your email inbox is getting better at filtering out all that junk mail you never signed up for. It's like there's a little helper working behind the scenes, making our digital lives smoother and more intuitive. This isn't magic, though it certainly feels like it sometimes. It's the result of something called deep learning. Deep learning is a powerful type of technology that has quietly become one of the most important forces shaping our modern world. It's the reason our gadgets are becoming less like tools and more like partners. At its heart, the idea behind deep learning is beautifully simple and inspired by the most amazing computer we know, the human brain. Think about how a small child learns to recognize a cat. You don't sit them down with a biology textbook and explain feline anatomy. Instead, you just point and say, "Look, a kitty." You show them a fluffy Persian, a sleek Siamese, a cartoon cat in a book, and a stray in the garden. Over time, without any formal rules, the child's brain starts to figure it out. It learns to identify the common features, the pointy ears, the whiskers, the tail, the meow, and builds a concept of what a cat is. Deep learning systems, in a very simplified way, try to copy this process. They are built on what's called a neural network, which is a digital structure inspired by the network of neurons in our own heads. Our brain has billions of tiny cells called neurons that are all connected, passing signals to one another. Take your phone's camera, for instance. When you switch to portrait mode, and it perfectly blurs the background while keeping your friend's face in sharp focus, that's deep learning at work. It has been trained on countless images to understand the difference between a person and the background, allowing it to create that professional-looking photo with a single tap. Think about the last time you watched a show on a streaming service like Netflix. When it suggests a new series and you think, "Wow, how did it know I'd love that?" That's deep learning. The system analyzes your viewing habits, compares them to millions of other users, and finds hidden patterns. Remember when online translations used to be clunky and often nonsensical? Now you can point your phone's camera at a menu in a foreign language, and it will translate the text for you in real time, right on your screen. This is an incredibly complex task. The deep learning model has to first identify the text in the image, understand the context of the words, translate them accurately, and then overlay the new text onto the original image. When your bank sends you a text message to flag a potentially fraudulent transaction on your credit card, that's often a deep learning system in action. It has learned the patterns of your normal spending habits, where you shop, how much you usually spend, what time of day you buy things. When a transaction appears that doesn't fit your pattern, the system flags it as suspicious. So, how does this neural network thing actually work? Let's forget the computers for a second and imagine we're trying to teach a friend, let's call him Bob, to decide if a fruit is an apple. Bob has never seen an apple before. To start, we can give him a few simple questions to ask. First question, is it red? Second question, is it round? Third question, does it have a stem? Now, let's make it a bit more sophisticated. We introduce another friend, Sarah, who acts as a manager. Bob reports his simple yes-no answers to her. Sarah's job is to weigh the importance of each answer. She might think, okay, red is a pretty good clue, so I'll give that a lot of weight. Round is also important. The stem is less unique, so I'll give that a little less weight. The key is feedback. Every time Sarah makes a decision, we tell her if she was right or wrong. If she sees a red, round, stemmed fruit, calls it an apple, and we say, correct, she learns that her current weights are good. But if she sees a red, round cherry and calls it an apple, we say wrong. This is where the learning happens. She goes back and adjusts her weights, gradually refining her decision-making process until she becomes a very accurate apple spotter. Now let's take our apple spotting team and make it, well, deep. Instead of just Bob and Sarah, imagine a whole company of people organized into different departments. The first department, the entry-level analysts, is only allowed to look for very basic things. One person just looks for the color red, another just looks for curves, a third just looks for straight lines. These entry-level analysts then pass their findings to the next department, the mid-level managers. This department doesn't see the original fruit. They only see the reports from the first department. One manager might get a report saying found red and found a curve and conclude, this could be a circular red shape. Another manager might see found a straight line and found some brown color and report, this might be a stem. Next, the reports from the mid-level managers go up to the senior directors. This third layer is even more abstract. A senior director might receive reports on circular red shape, a stem-like object, and a shiny texture, and combine them to form an even more sophisticated idea, like, looks like a piece of fruit. Finally, at the very top is the CEO. The CEO receives the comprehensive reports from the senior directors and makes the final, simple decision: apple or not an apple. So, we have this amazing layered network ready to learn. But how does it go from being a clueless digital baby to a smart expert? The process is called training, and honestly, it's a bit like creating millions of digital flashcards. To teach a network to identify cats, we don't write code that says cats have whiskers. Instead, we feed it a massive amount of data. In this case, thousands upon thousands of pictures. Each picture is labeled cat or not a cat. Initially, the network is a blank slate. All its internal weights, the importance it gives to each connection, are set to random values. So when you show it the first picture of a cat, its guess is basically a wild shot in the dark. It might say, not a cat, with 90% confidence. But since we know the correct answer is cat, we can calculate how wrong the network was. This error is the crucial piece of feedback. This is where the learning algorithm kicks in, a process often called backpropagation. It's a fancy term for a simple idea: passing the blame. The algorithm works backward from the final error, from the CEO's wrong decision all the way down to the entry-level analysts. It says, okay, we got this wrong. Which connections were most responsible for this mistake? It then makes tiny adjustments to the weights of those connections. If a connection contributed heavily to a wrong answer, its weight is reduced. This process is repeated millions of times, with each picture in the dataset. Show it a cat, it makes a guess, calculates the error, and adjusts its weights. Show it a picture of a dog, it guesses, calculates the error, and adjusts again. With every single example, the network gets a tiny bit smarter. Over time, these millions of small adjustments cause the weights throughout the network to settle into a configuration that accurately recognizes the patterns of a cat. If you think what deep learning does today is impressive, buckle up, because the future is even more exciting. One of the most mind-blowing areas is in medicine. Scientists are training deep learning models to look at medical scans, like MRIs and X-rays, and spot signs of diseases like cancer or Alzheimer's earlier and more accurately than the human eye. Another incredible frontier is creative arts and content generation. We're already seeing the beginnings of this with AI that can compose music, write poetry, or create stunning digital art from a simple text description. In the future, this could completely change how we create. A filmmaker could type a futuristic city at sunset in the style of Van Gogh, and the AI could generate a beautiful backdrop for a scene. Deep learning is also poised to revolutionize our physical world through robotics and self-driving cars. Today's robots are often limited to repetitive tasks in controlled environments like factories. Deep learning is giving them the ability to see, understand, and adapt to the messy, unpredictable real world. This could lead to helper robots in our homes that can assist the elderly, or advanced rescue robots that can navigate dangerous disaster zones. Perhaps one of the most profound applications will be in scientific discovery itself. We are collecting more data from experiments in fields like genetics, climate science, and astronomy than we could ever hope to analyze ourselves. Deep learning models can sift through these massive datasets to find subtle patterns and connections that no human scientist would ever spot. This could accelerate discoveries in every field, helping us find new materials, develop more effective drugs, understand complex ecosystems, and even unlock the secrets of the universe. With all this talk of super smart machines, it's easy to feel a little intimidated, or even wonder if we humans will become obsolete. But that's the wrong way to look at it. Deep learning is not a replacement for human intelligence. It's a tool to augment it. These systems are incredibly good at specific tasks, finding patterns in massive amounts of data, but they lack the common sense, emotional intelligence, and ethical judgment that we humans possess. The machine can analyze 1 million medical scans, but it's the human doctor who must deliver the news to a patient with compassion and help them decide on a treatment plan. Our role is shifting from being the doers of every task to being the directors and ethicists of the technology. We are the ones who decide what problems deep learning should solve. Furthermore, the most powerful applications of deep learning will come from human-AI collaboration. Think of a chess grandmaster using a computer to explore new strategies, or an architect using an AI to generate hundreds of building designs to spark inspiration. The AI can handle the heavy lifting of data processing and pattern recognition, freeing up our minds to focus on the things we do best: creativity, strategic thinking, and complex problem solving. So, there you have it. Deep learning isn't some distant, complicated science fiction concept. It's a technology inspired by our very own brains, built on the simple idea of learning from experience, layer by layer. It's already the silent partner in your pocket, making your phone smarter, your entertainment more personal, and your daily life a little bit easier. From a simple portrait mode on your camera to complex systems that can help doctors save lives, deep learning is a powerful current reshaping the shores of our modern world, and it's only just getting started. This isn't just for coders and engineers, it's for parents, artists, doctors, and anyone who is curious about the future and our place in it. This is your invitation to stay curious. The next time your music app suggests a song you instantly love, or your phone magically organizes your photos, take a moment to think about the deep learning working behind the scenes. The journey of deep learning is just beginning, and it promises to be one of the most exciting adventures of our lifetime. By understanding it, you're not just watching the future unfold, you're ready to be an active participant in shaping it.